right? So V1, Jessica's V1, you don't have to be perpendicular. Let's not be perpendicular right now. So Jessica's V1, who's V2? Sean? Sean's V2, and then Jana's V3, right? Okay, now let's take Jana out of the picture for now, and we're going to do a projection from, what's our projection from? Is it from Sean to Jessica, or from Jessica to Sean? V1, V2. What's this projection? What? Onto V1, right? Onto V1. So what is that projection? Sean to Jessica. I need somebody to be that projection. Volunteer? Alex, it's a projection from Sean to Jessica.
Wait, like Sean on.
Sean onto Jessica. Projection. Is that what we want?
No.
No? Natalie, what do we want?
No,
It should be like on Jessica's.
On Jessica's vector.
It's not on.
What we can imagine.
So this part here is Alex right now. Right? Just the projection. Right? So this part here is Alex. Right? So now I want W2 to be the difference between Sean and Alex. I need somebody to be W2. W2. Anybody? You guys have to stop moving now. Need a ruler. This one. All right. Ainsley's now W2. I don't know if you guys noticed, but this is all happening in 2 dimensions. Right? This is all happening in the plane. Can I take Alex and Ainsley out again? Temporarily. So these 2 vectors form a plane. Right? They form a plane. Can anybody be the plane?
Come on, Ethan, you look like you want to do it.
I have to watch this because I'm so.
Can anybody be plane?
I'll be the plane.
So Jessica and Sean span a plane, span a 2-dimensional plane. Right? They span a 2-dimensional plane. Now, those 2 vectors span a plane. Let's put Ainsley back. So she's W2. Who's V2?
Sean.
Sean is V2, right? So if we take Sean out of the picture, Ainsley and Jessica will be spanning the same plane as Sean and Jessica were, but now they are orthogonal to each other. Right?
Wow.
So Jessica, who's V1, she's also W1, but now Ainsley's W2, and now we've created 2 vectors that are perpendicular to each other. Okay? Does that make sense so far? So that's our first step. Can you ask a question? Let's show the screen. What's happening here so far?
Wait, what was Jessica when I was born?
So Jessica was V1, but she's also W1. It's the same thing. All right. Sean's V2. We decided to project Sean onto Jessica, and that was Alex. Right? Alex was just this part right here. And now we subtracted Sean minus Alex, and we got Ainsley. And now Jessica and Ainsley are perpendicular to each other. And they span the same plane that V1 and V2 span. That was Natalie's plane. Does that make sense? All right. Let's put Sean, Jessica, and Ainsley again. You can go there real quick.
I was just thinking projection of Sean Jessica.
Yeah. So remember where the projections came from. Remember where Ainsley came from, right? It's a projection. It's a difference between those two vectors.
Yeah.
This one.
All right. Alex, step out, and Natalie, go back. So right now they're on the plane, right? Let's put Gianna in the picture. So Gianna is now the third vector, right? And what does the third vector do? The third vector, V3. We need to project V3. This is the tricky part. We need to project V3 onto the plane, onto the same plane that has V1 and V2. All right? So I'm looking at this formula. I don't see any V2s here. I'm going to get rid of Sean. Take Sean out of the picture for now. I see V3 with W1. Jessica's W1. Who's V3 again? V3 is Gianna. So now we're going to project. So this expression over here, sorry. So what we want to do is we want to project Gianna's vector onto the plane, onto Natalie's plane, right? That's what we want to do. And to do that, you need to use the W1, which is Jessica, and the W2, which is Ainsley. And then these things span a plane, so this thing is going to drop down here. So, I don't know if you guys can see, but over here, these two expressions here will represent something that's on the plane, on Natalie's plane, right? So we need somebody to be on Natalie's plane that's going to be the projection of Gianna's vector onto these two vectors. Can I have another volunteer? So where do you think Colin has to be? You're projecting Gianna's onto Natalie, essentially. So Natalie's plane originally came from Sean and Jessica, but Sean got taken away and got replaced by Ainsley. So Natalie's plane comes from Jessica and Ainsley, right? So where are you going to go?
Here.
All right, so Colin is on the plane, right? Colin is on the plane. Colin is on Natalie's plane, and Colin is actually being represented by a linear combination of W1 and W2 of Jessica and Ainsley, which is on the plane. So now this W3 has to be V3, has to be Gianna minus Colin. These two vectors, or these two expressions here, this is Colin right now on the plane. So I need another person to be W3. Who's W3? I need a W3.
Come on, Robert. You're thinking about it.
Yes, sir, Robert.
Come on, Robert. You got it. You want a stick?
I can do it.
You want a stick?
No, here he
You
is.
want it? Am I still needed for this?
Maybe, I don't
I'm the
know.
projector. I'm the
You
projection.
are the difference between Gianna and Colin.
Like this.
Yes. So Adam now is going to be the difference, the V3, that's Gianna, minus Colin, which is the vector on the plane. That's the projection on the plane. Okay, so that's W3. Now, if we move Adam, put this guy on the plane, but have it the same direction.
Oh. Just like shift to there.
Yeah, I don't see perpendicular with mine.
Adam should be actually perpendicular to Natalie. Natalie's the plane. Adam has to be perpendicular to Natalie. Because remember, Ainsley and Jessica are on the plane. They're already perpendicular to each other. Now we just created another vector, a third vector, that is perpendicular to these two vectors that are already here. Right?
So we took 3 non-perpendicular vectors and
Mine's the projection of Gianna.
Yes. So you took 3 non-perpendicular vectors. Jessica, Sean, and Gianna were non-perpendicular, but now you've created something perpendicular. So what do we have? Let's take the plane out. Let's take the projection out. Let's take V3 out. We have 3 vectors that are now perpendicular to each other. Does that make sense?
Yeah.
And all you need to do is to make each of them into a unit vector. Okay. Is to make each of them into a unit vector, and now you have 3 orthonormal vectors. Does that make sense? Yes.
Yeah, so like an orthonormal vector would be like it looks kind of like a corner of a cube in a way.
Yes, exactly. It's a quarter of a cube. They're all perpendicular. They're all the same length. Yeah.
So is that like related to the TMB frame?
Yes, this is exactly the TMB frame.
Okay.
Any other questions? The TMB frame are all orthogonal and they're all unit length. Ethan?
So I like understand generally how it works, and maybe this is just because I was late, but how does all that like inner product stuff give us a projection?
That's how we define projection. From the dot product to the inner product.
Okay.
Yeah. Okay? Does that make sense? Yay! Thank you.